In the last period, we have seen the term angular displacement. Today, we will see the next term, that is another term, that is angular velocity. What is meant by angular velocity? Angular velocity omega is defined as it is the rate of change of angular displacement with respect to time. It is the rate of change of angular displacement with respect to the time, that is known as angular velocity. To obtain an expression for angular velocity, see, we will see that a particle is performing a circular motion in anti-clockwise direction. A is the initial position, R is the radius vector. This particle starts from the initial position A and reaches to the final position B in a time of t second. So, this theta will be the angle described by the radius vector at the center of circular motion. Theta is the angular displacement. Then, the angular velocity is given by change in angular displacement upon time. So, change in angular displacement is a theta, that is angle between initial position and final position. That is the change in angular displacement. This change in angular displacement is a theta, t is the time, and omega is the angular velocity. In this way, we get an expression for angular velocity. Omega is equal to theta upon t. Its unit is radian per second. Because the unit of theta is radian, unit of t is second, so its unit will be radian per second. So, to find the dimensions of angular velocity, to find the dimensions, omega is equal to theta upon t. Then the dimensions of theta, theta is angular displacement, is a dimensionless physical quantity. It has no dimensions, so its dimensions are m to the power 0, l to the power 0, t to the power 0. And the dimensions of the time are t to the power 1. Then the dimensions of omega will be m to the power 0, l to the power 0, t to the power minus 1. And these dimensions of angular velocity are just similar to the frequency. That is, dimensions of frequency and dimensions of angular velocity are one and the same. Then we will see the nature of this physical quantity. The nature of whether this physical quantity, angular velocity, is a vector quantity or a scalar quantity. As we have discussed in angular displacement, if angular displacement theta is a finite, angular displacement theta is finite, it means arc length AB is greater than the chord AB, then angular displacement theta is a finite and angular velocity is also finite, and it is a scalar quantity because it do not obeys the laws of vectors. So in the second case, when this angular displacement theta is infinitesimally small, it means arc AB and chord AB are same. Then the angular displacement theta is infinitesimally small. It obeys the laws of vectors. Therefore, angular velocity is a vector quantity which has magnitude as well as direction. So, angular velocity is always perpendicular to the plane of circular motion. Because in physics, there are 5 physical quantities which are axial vectors. This is a very important thing. Every student should remember this sentence. So in physics, there are only 5 physical quantities which are axial vectors. See, first one is angular displacement, angular velocity, angular acceleration, angular momentum, and torque. So these are the 5 physical quantities which are governed by right hand rule only. They are always governed by the right hand rule only. So the direction of angular velocity is also given by a right hand rule. So what is the right hand rule? If this particle is performing a circular motion along the circumference of circle, imagine the axis of rotation is held in a right hand with outward stretched thumb. If the tips of curl fingers of right hand represents the sense of circular motion, then this outward stretched thumb will represent the direction of angular velocity. In the same way, if the particle is moving in a clockwise direction, then this is the axis of rotation. Held this axis of rotation in this fashion. Held the axis of rotation in a right hand with outward stretched thumb. And if the tips of curled fingers of right hand represent the sense of circular motion, then outward stretched thumb will give the direction of angular velocity, which is in a downward direction, and it is taken as a negative. So the sign conventions of angular velocity will be like this. If a particle is performing a circular motion in anti-clockwise direction, then according to right hand rule, angular velocity will be in upward direction and it is taken as a positive. If the second sign convention is that if a particle is revolving in a circular motion in a clockwise direction, then held this axis of rotation by right hand like this with outward stretched thumb, then the resultant vector will be in a downward direction and it is taken as a negative. It means for clockwise circular motion, omega is a negative, and for anti-clockwise circular motion, omega is positive. The diagrammatic representation of the sign convention is like that. If the particle is revolving in anti-clockwise direction, then angular velocity is in upward direction and it is taken as a positive. That is for anti-clockwise circular motion. And if a particle revolves in a clockwise direction, so like this, the angular velocity omega will be in a downward direction and it is taken as a negative. Then after that we will see the cross product or vector product of angular velocity. Vector product or vector form of the angular velocity. Vector form of the angular velocity always comes with a limit. It means we are defining this angular velocity for a small interval of a time. That small interval of a time just tends to 0. So angular velocity omega is equal to limit delta t tends to 0 d theta by dt. So this d theta is the small angular displacement in which the arc AB and chord AB exactly equal. Arc AB and chord AB are exactly equal. So this form is a form of angular velocity, vector form of angular velocity. Then after that, we will see in a circular motion, angular velocity is always perpendicular to the plane of circular motion. velocity is always tangential to the circular path, and this one is the radius vector. So, angular velocity is always perpendicular to the plane of circular motion. Velocity is always tangential to the circular path, and radius vector is directed from center to circumference. To find the cross product of this omega, r and v, we will make an arrangement. Small changes will be made here. That this is a negative radius vector r. This is a negative radius vector, and this is omega is taken parallelly shifted here, and velocity is a tangential to the circular path. So these are three vectors. This is a velocity vector which is tangential to the circular path, angular velocity omega, and this is a negative radius vector. Negative radius vector means radius vector is directed from center to circumference, and this vector is directed from circumference to center. So assign each vector along this each finger. So this relation between these three vectors can be established by right hand rule. So stretch three fingers, that is a forefinger, middle finger and thumb mutually perpendicular to each other, and assign each vector along the direction of each finger. So this forefinger will represent the velocity. Then central finger will represent the negative radius vector, and thumb will represent the angular velocity omega. Angular velocity omega. So see this. This is forefinger which represents the angular velocity. This is middle finger or central finger represents the negative radius vector, and this represents the angular velocity omega. And we are interested in finding the equation for linear velocity. Then put this vector in upward direction. So this is a velocity. So this is a first vector in cross product. This is a second vector in cross product. And cross product of these two vectors gives this resultant vector, that is a velocity. So this vector is minus r. Minus r multiplied by omega is equal to v. But there is a negative sign, so we have to reverse the sequence of multiplication. In case of r cross omega, we will reverse the sequence omega cross r. So the cross product of velocity will be v is equal to omega cross r. Velocity v is equal to omega cross r as shown in figure. So v is equal to omega cross r. The next definition in circular motion are time period. What is meant by time period? It is the time interval required for a particle to complete one revolution. That is called as a time period. So it is a time interval required for a particle to complete one revolution, that is called as a time period, and it is represented by capital T. Then another definition is a frequency. What is meant by frequency? It is the number of revolutions completed by a particle in 1 second. See this. It is the number of revolutions completed by particle in 1 second, that is called as a frequency of revolution. Its unit is cycles per second or hertz. Then relation between time period and frequency is established like that. So time period is equal to 1 upon frequency, that is t is equal to 1 by n. The reciprocal of frequency is the time period or vice versa, that is the reciprocal of time period is the frequency.